This was the first shock because anything from ancient Greece simply shouldn't have gear wheels. These were precision gears with teeth about 1 millimeter long. And this was just completely shocking.
We have just found a mysterious bronze device beneath the depths of the Aegean Sea. After years of research, scientists discovered it is not just any artifact, it is a 2,000-year-old computer. That's right.
It's an analog computer. It doesn't use digital. It uses wheels and gears. This was a device that we wouldn't see again for another 2,000 years until the 1800s.
Built at a time when there were no mechanical clocks, no precision instruments, and certainly no digital technology. So how is this possible? And the most terrifying part is, what did they find in it? Discovery of a lost wonder. The year was 1900, and the Mediterranean Sea was dotted with ships carrying goods, people, and stories between the coasts of Europe, Asia, and Africa. Sea trade was the lifeblood of ancient civilizations. The waters of the Aegean Sea in particular served as a highway for commerce. It brought wealth and culture from one shore to another. Merchant ships carried everything from wine and olive oil to rare spices, textiles, and even precious metals and works of art. However, these voyages were anything but safe. The sea was a treacherous place where storms brewed unexpectedly and piracy was a constant threat. For a merchant, the promise of fortune was always shadowed by the risk of disaster. In the spring of 1900, a group of sponge divers from the island of Symi, off the coast of Greece, were preparing for yet another dangerous dive. Sponge diving had been a way of life for these men, passed down through generations. With rudimentary diving suits and helmets, they descended into the cold, dark waters, hoping to bring up the sponges that would sustain their livelihood. The divers, working together from a small wooden boat, knew the dangers well. There were strong currents, the risk of running out of air, and the deep pressure that could crush a human body in seconds. On one such dive near the rocky island of Antikythera, a young diver named Elias Stadiatis plunged into the depths. Not knowing that he was about to make one of the greatest archaeological discoveries of the 20th century, the water grew darker as he descended, and his eyes adjusted to the dim blue haze. Suddenly, a glint of something unnatural caught his attention. As he drew closer, he saw what appeared to be the outline of a shipwreck scattered across the seafloor. The wreck was a tangled mess of decaying wood, bronze, and marble, half buried under centuries of sand and silt. In the midst of the debris, he saw something strange hidden in the shadows. It was a corroded bronze hand, fingers curled, jutting out of the mud as if frozen in time. Elias signaled frantically to be pulled to the surface. Breathless and wide-eyed, he described what he had seen to his fellow divers and the captain. At first, they thought he was hallucinating from the pressure, but curiosity won over skepticism. A team of divers descended to confirm his findings, and what they discovered left them speechless. Scattered across the seabed were marble statues of gods and heroes, bronze sculptures, amphorae, and other relics that hinted at an ancient treasure trove lost to the sea. Word quickly spread, and soon the Greek government organized a major recovery effort, working alongside the divers to bring the artifacts to the surface. The operation was not an easy feat. The shipwreck lay over 150 feet below the surface, a depth that pushed the limits of the divers' primitive gear. Every ascent was a dangerous journey, but the promise of buried history was irresistible. Piece by piece, the relics emerged from the depths. They found a magnificent bronze statue of a youth, fragments of marble busts, vases, jewelry, and even remnants of the ship's wooden hull. It was the largest collection of ancient Greek artifacts ever found in a single site, and the archaeologists were overjoyed. The treasures were carefully transported to Athens, where the National Archaeological Museum became the site of daily research. Scholars and experts worked day and night to piece together statues and examine the intricate pottery. However, among the bounty of relics, one corroded lump of bronze seemed almost insignificant. It sat in a corner, a misshapen block that no one quite knew what to make of.
It was not recognized at all as being anything interesting when it was discovered. It was just a corroded lump about the size of a large dictionary.
At first, it drew little attention, It was cracked and covered in a thick layer of corrosion from centuries under the sea. But as it dried out over the following months, something incredible happened. The corrosion began to flake off, and beneath the surface were signs of something mechanical. Gears, wheels, tiny inscriptions in ancient Greek. A team of scientists gathered around, puzzled and intrigued. What could this object be? They realized they had uncovered something truly extraordinary. They had found a machine, impossibly complex for its time, a device that would come to be known as the Antikythera mechanism. Valerios Stais was a Greek archaeologist who was one of the first to propose that the device was some form of ancient astronomical instrument. But mechanical devices this sophisticated were not supposed to exist in antiquity. Mechanical clocks would not be invented until 1400 years later during the Renaissance. As more and more gears were uncovered, the mystery only deepened. This was not just a simple clock or astrolabe. It was a highly advanced analog computer capable of calculating astronomical positions with extraordinary precision.
I think it was conceived as a calculating machine that would calculate the theories they had. They had astronomical theories. You could look ahead, say, what's the position of the moon going to be in 5 years' time? You could turn the handle. They'd tell you almost immediately.
Excitement spread through the halls of the museum as experts from different fields came together to puzzle out the truth behind the Antikythera mechanism. So what theories did those great minds come up with for this strange device? All the crazy theories. When Greek archaeologist Valerios Stais first studied the bronze fragments of the Antikythera mechanism, he was astonished. He noticed gears, actual gears, inside the corroded mass and proposed that it could be some sort of ancient clock. A clock? In the ancient world? Most historians scoffed at the idea. They had always imagined the Greeks as philosophers and sculptors, not builders of precision machinery. The notion that people from over 2,000 years ago could create something so intricate seemed like a fairy tale. But as more pieces were studied, it became increasingly clear that this was no ordinary relic. And that's when the theories started to get a bit out there. Some people began linking the Antikythera mechanism to the legendary lost city of Atlantis. They suggested that this device was a leftover piece of advanced technology from a civilization wiped off the face of the earth. To them, the mechanism was proof that Atlantis was real and that its inhabitants were way ahead of their time. This sounds crazy, right? Well, it only gets wilder. Others took it a step further and argued that the mechanism was evidence of alien intervention. Yes, aliens. They claimed that there was no way humans from that era could have created something so advanced without a little help from extraterrestrial visitors. The idea of aliens dropping by ancient Greece to share their technology certainly makes for a great sci-fi movie plot. And in fact, it has inspired quite a few books and documentaries. But as fun as these theories are, most scientists prefer explanations that don't involve little green men. Instead, researchers dug deeper into the cultural beliefs of the ancient Greeks to figure out what this device could have been used for. One popular theory focuses on astrology. The Greeks were obsessed with the stars and believed that celestial events could influence life on Earth. They tracked the movements of the planets and the phases of the moon, believing that these could foretell everything from the success of a military campaign to the outcome of a marriage. So, could the Antikythera mechanism have been used to predict the future? It is certainly possible. Some scholars think that the mechanism may have been used to cast horoscopes. In ancient Greece, wealthy individuals and powerful rulers often paid astronomers handsomely to map out their fate using the positions of the planets. The Antikythera mechanism, with its complex gears and inscriptions, could have been a tool to pinpoint these cosmic positions with impressive accuracy. Imagine you could set this device to your birthday and have it tell you exactly where each planet was in the sky at that moment. It would have been fascinating, right? For astrologers of the time, it would have been like having a supercharged horoscope machine. But astrology was not the only thing on the table. As experts examined the mechanism further, they realized it did a lot more than just map out star signs.
This was a wonderful revelation. Out of that data has come nearly all the breakthroughs in recent decades. Came the discovery that it predicted eclipses, that it followed the variable motion of the moon.
The device could predict eclipses and even track the cycles of the Olympic Games. This opened the door to other theories. Some suggested that the mechanism was a teaching tool, used by scholars or philosophers to explain the movements of the heavens to students. Another possibility was that the Antikythera mechanism could have been a luxury item for the elite. Owning a device that could model the universe would have been the ultimate status symbol, a display of wealth and knowledge that few could rival. In this view, the mechanism was about science, yes, but also about prestige and power. Now, which theory proved right? What did they find out upon further research? Technological breakthroughs. Understanding the Antikythera mechanism was no easy feat. When it was first pulled from the Aegean Sea and dusted off in the early 1900s, scientists had no idea what they were dealing with. The corroded lump of gears and fragments looked more like a mess of ancient junk than anything meaningful. Back then, technology to investigate such an artifact was practically non-existent. Researchers were left with basic tools and, honestly, a lot of guesswork. The first attempts to understand the mechanism were full of excitement, but let's be honest, pretty limited in what they could achieve. John Svoronos was among the early investigators who saw potential in the fragments. He examined the artifact and was awestruck, but could only do so much without modern imaging technology. Albert Rehm, a German philologist, was another pioneer. He carefully studied the inscriptions on the device and came up with the idea that it was an astronomical calendar, but even he could not piece together how the gears function. The mechanism remained a mystery for many years. Then came 2 world wars, and all that excitement ground to a halt. The world was in chaos and scholarly research stopped altogether. The Antikythera mechanism sat in storage, gathering dust, waiting for a time when the world could once again focus on the wonders of the past. It is almost poetic in a tragic sort of way. A masterpiece of ancient engineering, forgotten and overshadowed by the madness of the 20th century. Then came the 1950s, and the world was ready for a fresh look at the device. This is when Derek Price entered the scene. He was a historian of science from the UK. By this time, X-ray technology had made significant strides, and Price was determined to use it to study the Antikythera mechanism. His X-ray scans revealed that the mechanism had far more gears than anyone had imagined. Based on his findings, he built the first working model of the device and called it a calendar computer. But this model was not quite right. It was impressive, sure, but to make it work, Price had to change the number of teeth on some gears. He knew his reconstruction was not perfect, but it was a big step forward. Then came the real game changer, 3D tomography. In the early 2000s, technology had advanced to a point where scientists could create detailed, 3-dimensional images of objects. This technique allowed researchers to see inside the fragments of the Antikythera mechanism with unprecedented clarity. Michael Wright, a curator at the Science Museum in London, was one of the key figures who took this new technology and ran with it. He spent years carefully scanning, measuring, and creating a more accurate model of the mechanism. Unlike Price, Wright didn't need to change the gear teeth. His version worked just as the ancient Greeks intended. But the story does not end there. Tony Freeth, a mathematician and filmmaker, was not satisfied with just one breakthrough. He gathered a team of experts under the Antikythera Mechanism Research Project. Using even more advanced imaging technologies, like high-resolution X-ray tomography, they captured the finest details of the inscriptions and internal components. The clarity was astonishing, and their work revealed secrets hidden deep within the stone. There were tiny letters and numbers that helped explain how the mechanism worked.
A dedicated calculating machine, and it uses bronze gear wheels to calculate the cycles of the cosmos being the sun, the moon, the planets, against the stars.
Thanks to the research, we now know that the Antikythera mechanism was an intricate astronomical computer that mapped out the movements of the sun, moon, and planets, even predicting eclipses. Meanwhile, the search for more pieces of the puzzle continued underwater. Jacques Cousteau, the legendary ocean explorer, made it his mission to revisit the Antikythera shipwreck in 1953. Equipped with more advanced diving gear than the original sponge divers, Cousteau and his team searched the depths for days. They found more artifacts, including statues and pottery, but no new pieces of the mechanism. Even so, Cousteau's dives reignited public interest in the mystery. Later expeditions were even more high-tech. Modern divers, equipped with robotic submersibles and specialized underwater imaging equipment, have returned to the site multiple times. Each expedition brings hope of finding more fragments of the mechanism or even other treasures lost to the sea. The Antikythera shipwreck has become a treasure trove of ancient history, and the hunt for new discoveries continues. Maybe someday we will find more. But for now, let's look at the incredible discovery we have now. The Antikythera mechanism. At first glance, the Antikythera mechanism might look like a corroded piece of junk, but beneath the rusted exterior, it was a technological marvel lying in a shipwreck. It was a complex system of gears and inscriptions that have kept scientists guessing for over a century. The front face of the mechanism has several dials that represent different celestial phenomena. One of the main dials tracks the movement of the sun and moon across the sky. It even accounts for the moon's irregular orbit, a detail that shows just how well the ancient Greeks understood astronomy. As you turn a small hand crank on the side, the gears come to life, moving pointers to show the positions of the sun and moon relative to the zodiac constellations. Then there is the back of the mechanism, which is equally impressive. It has two large spirals that serve different purposes. The top spiral tracks the 19-year Metonic cycle, which was crucial for the ancient Greek calendar. Every 19 years, the phases of the moon repeat on the same days of the year. So this cycle is important for predicting lunar events. The lower spiral is an eclipse predictor, showing when and where eclipses would occur. It's almost mind-blowing to think that this device could predict something as rare and significant as an eclipse with surprising accuracy. So how did this ancient computer actually work? Let's simplify it. Think of the gears as the mechanism's brain. Each gear is connected in such a way that when you turn the crank, they all move in perfect synchronization, just like the wheels of a clock. But instead of just telling time, this clock tells the story of the universe. The gears work together to mimic the movements of celestial bodies, with different ratios accounting for the unique orbits of the moon, sun, and even the 5 planets known at the time: Mercury, Venus, Mars, Jupiter, and Saturn. One of the most impressive aspects of the mechanism is how it simulates the moon's orbit. The moon does not travel in a perfect circle around the Earth. Its path is more like an elongated oval, speeding up and slowing down at different points. The ancient Greeks understood this well enough to incorporate it into the mechanism. A clever arrangement of gears and a pin and slot mechanism adjusted the speed of the moon's movement, making the simulation far more accurate than you would expect from 2,000-year-old technology. What's even more incredible is that this device operated on a geocentric model of the universe, which means it depicted the Earth as the center of everything. While we now know the heliocentric model is correct, this geocentric model was widely accepted at the time. Despite working from a scientifically inaccurate premise, the Antikythera mechanism's design still managed to map out celestial movements with impressive precision. Now let's not get too carried away with its brilliance. The Antikythera mechanism, as groundbreaking as it was not perfect. For one thing, the device had mechanical errors. The gears, while precise, weren't as flawless as the ones we can produce today with modern tools. Over time, even the tiniest misalignment would throw off the mechanism's accuracy. Plus, the ancient Greeks didn't have telescopes or modern instruments to make precise astronomical measurements. They based their calculations on observations made with the naked eye, which means there were inherent limitations in their understanding of the universe. The mechanism was also prone to wear and tear. Let's face it, bronze gears and wooden casings don't hold up perfectly over centuries. Even back then, the machine's accuracy would have gradually deteriorated with use, making it less reliable over time. Despite these flaws, the mere fact that it worked at all, and did so as well as it did, is nothing short of miraculous. Today, the Antikythera mechanism continues to inspire awe and wonder. It has influenced modern research into the history of science and technology, sparking questions about what other marvels might have been lost to history. This makes us wonder, if the Greeks could build something so advanced over 2,000 years ago, what else did they achieve that we haven't discovered yet? Could there be more groundbreaking devices lost to history, still waiting to be unearthed? Tell us your thoughts in the comments below. If this story has you intrigued and curious, make sure to subscribe for more fascinating mysteries and discoveries. See you in the next video.